So, hello everybody. I'm really happy to welcome you on our third day of the conference and on our architecture and DevOps teams track. And now we will start with, I hope, a great session from made by Sean Faramr. Hello, Sean. Nice to meet you.
Hello.
Yeah, so Sean will tell us about DevOps and microservices better together. So I have kind of, let's say, offensive question at the beginning. So with your, let's say, whole experience, it's the work that the work which should be done once, or it's the process which must be done continuously or on our daily basis.
Do you mean about DevOps and microservices, or
Yeah,
about
yeah,
design, or
yeah, yeah.
it's a culture. It's a culture more than anything. Yeah, you have to live it in order to make it work. Yeah,
Yeah, so it requires
because
changing mind
whatever you
people. Yeah.
yeah whatever you think is right today, you'll find out tomorrow that that didn't work. We need to improve. And one of the biggest thing about Kanban and continuous delivery is all about learning every week if you can from your mistakes and making it better. If you don't, then you're not. Yeah, it's, it's a waste of time if you don't learn.
Yeah. Yeah, exactly, exactly. Okay, so the floor is yours. Keeping fingers crossed and have fun.
Thank you very much. I'll try. I just need to share my screen if I can find it. Uh, Sorry about that. Yeah, I hope you can see my screen now.
Yes, we can.
Oh, good, good. Okay, so hi everyone. Good morning or good almost late morning in Lithuania. Um, my name is Sean Faramr, and I've been doing software for, I don't know, since '94 or something like that. And I'm going to talk about why microservices and DevOps are such close friends, good friends. And I'll start by telling you a little bit about my story. Um, So back in the day, that was like '94. Yeah, I started coding in a company. Back then, the internet wasn't really a thing, and we were doing multimedia. So if anybody heard of this ancient thing, but yeah, we're burning CD-ROMs, putting titles together, and basically delivering hard CD-ROMs to the customers. Yeah. So the process was very kind of cowboyish, as you see on the picture. So I used to get the storybook, go through the storybook, code it as a title, burn a CD, take the CD, give it to the testers. The set testers would then run through the CD, usually it would be a game or a title or a tutorial or something, and that'd be like letting me kind of giving me a list of bugs. I kind of go back, fix the bugs, burn a new CD, and that went on for multiple times. And once we were happy that this is like, yeah, it's good enough, then we burnt what was called the Gold Master, yeah, and that Gold Master went to production and was printed and sold in the market. So obviously there was like no version control. Like the best version control that I had was the files on my local desktop. We didn't have unit test. There was no versioning. Everything was manual. Everything was like done one for one. So a couple of years later, like we're talking like around 2000, I started building. The internet was a thing now, and I started building dynamic websites. Yeah, so I wrote a bunch of ASP this is ASP pages, I guess, code files. And obviously, when you deploy them, they ran on the server. There was an interpreter that delivered the HTML from using the ASP code. So basically, I was like writing the code kind of deploying it onto the server to production, yeah, and then hacking the SQL Server in production and making everything work. And yeah, there was like, still very cowboyish. There was no unit test. The best test was just to put it in production or to my local machine and try and run it and see if it works. There was no, like, again, source control was more of kind of every time I thought I had something good, I put it into a zip file and started. And if there was any issues in production, I just went on to kind of, RDP onto the machine and make some changes, yeah, using, as of course, SA, right, as the username and password. Security was wild back then. But then, like I moved to Ireland in 2004, and I worked for a couple of blue chip companies in Ireland, and we did have source control, and it was terrible, but we had source control. I don't even think I need to mention the name because nobody will know what it is. And now we were compiling code and zipping the DLLs and the resources. It was like a mix of HTML and resource DLLs. This is now ASP.NET, the very old versions of that. Then I was, I'd compile the zip and drop it onto a file share, and operations would deploy to a UAT or a test machine. And then when the cycle of testing and civilization was done, we went to production. Same process, yeah. They took the zips that were the base for the tests and deployed them in production. Of course, they had like, I don't know if you've seen it ever, but they had like documents of Word documents with detailed instructions with screenshots of how to deploy this code onto production, onto the server, yeah. Still, I was, every time there was an issue in production, I would still RDP into the machine and go directly into SQL and change I don't know if anybody uses store procedures anymore and functions, but back then that was something very, very much alive. So yeah, just go in. So of course, those changes never made it into production, into source control or anything like that. So, I was building, what was the classic monolith based on the best practices at the time. And every so often there were new best practices. So we moved from kind of monolith, kind of, 2 layers to 3 layers to N tier to services and all kind of layers and tiers, all best practices. But at the end of the day, it was still a monolith, right? So we're gathering requirements again, and they were signed off by the business, and then we put together a BDR, a business requirement document, that took like best part of 3 months, and then I wrote I was the tech lead there, so I kind of wrote the technical specs. It took hundreds of pages of technical specs that no one read, of course. And then we finally got to the stage where we could start coding, and we started coding. So after 6 months of work or so, we handed over the code again to the testers, and they were running their manual Excel spreadsheet use cases. I don't know, you probably saw this before. And, we completed this cycle of bug fixing, regression testing, bug fixing, regression testing, and then deployed it to UAT. So this is 9 months later. This is the first time the business ever saw anything, right? And they were horrified, yeah? In many occasions, they were horrified. They were looking at it going like, this is not what we asked for. No, this is not what we want. This doesn't look right and all that. So, we kind of went into this cycle of change requests and sometimes even a whole redesign. Needless to say, this is like was soul destroying. Yeah, it was like it you know, it kind of made me never want to start another project again. But you know, I probably have a survival mechanism or just a hopeless optimism that makes me think that I can do it better next time. You know, next time around it'd be better. You know that, and it reminds me of the saying, you know, like doing the same thing over again and expecting different results is the definition of insanity. But I guess we're all a little bit off the hook here, because we're a little bit crazy if we do development. So yeah, so now we move on to 2009 roughly. That was like kind of a couple of years later, and I always felt that we can do this thing better. You know, like the this is wrong. There's something absolutely wrong, because this is now I had probably 10 or 15 projects under my belt of full delivery, and I've seen this happen again and again and again, and it's like it was crazy, right? And I moved to another company, and this company was doing this agile thing, and I even kind of brought in a whole transformation there, but that's a story for another day. And around 2009, I started hearing, you know, on the web and all that, started hearing about 10 deployments a day at Flickr, and the term DevOps kind of emerged, and Lean Kanban and infrastructure as code, and it sounded really exciting, but and it made sense, you know, when you kind of read the details, it kind of said, yeah, sure, but it looks like this is for unicorn stuff, you know, like I would never be able, you know, like I'd never be able to do something like that on my own systems. It's like just like I can't find the match here, yeah. And only later, you know, in 2013 or so, I read this book, and it's a treasure. I don't know if this came out 2016. In 2013, I read the Phoenix Project. It's like more of a novel than a technical book, but it was brilliant, and it really kept me motivated. And then reading the DevOps book is confirmed all my kind of thinking, I guess. But I'll tell you a little story later. But there's one kind of theme that goes through this handbook and through other books like Accelerate. There is a theme that says that the architecture is an enabler here. You know, part of the enablers. I'm not saying it's the only one, but architecture is probably the strongest enabler for continuous delivery. And in the book it says, and I'll read from the slide, you need to have an architecture that's modular, encapsulated, and loosely coupled, so that small teams are able to work in high degree of autonomy, with failures being small and contained without causing global disruptions. So, you know, basically in two words, microservices, reliable microservices, yeah, in today's world, I guess. So let's see, how do we, you know, where does that come from in the book, at least, yeah? So they did a couple of case studies, and they put forward the case studies around eBay, Etsy, Google, Amazon, and LinkedIn. All of them are obviously in our world. I hope that we can agree on that. They're all unicorns. Yeah, these are none of us, or very little of us, would actually build any of those systems today. Yeah, and these are huge companies, huge systems, huge that. But they came from small things. Yeah, they all started off as monoliths. Yeah, they all started with very monolithic architecture. I think it's eBay or something like that that got to the limit of the compile limit for C++ or something, that they basically couldn't write any more code, because if they would, it would kind of, you know, they had like that classic God object, if you wish, yeah. But they all made this leap of faith, I guess, and went into the microservice. Back then, it was service-oriented architecture, which this is where I come from. They all moved to those kind of some sort of microservice architecture, all obviously different in different implementations, different styles and all that, but they all found their way around that to enable them to get to this continuous delivery, to move fast, to deliver quickly, to have resilient systems. Yeah. So when I try to look at it in my little world, in my project, I immediately hit this wall. Yeah, it's a beautiful wall, by the way. But and the wall was my monolithic architecture. Yeah. As a result of the architecture we had in our project, it was like we're doing big batches of work. We had big bang deployment, all or nothing. There was no, backward only kind of rollbacks. Yeah, if something happens, we could only go back to our backups. Yeah, whatever. And we had long feedback loops. Yeah, from the time we started, by the time we deployed, by the time it went into production. Sometimes you move on to another project by the time whatever you build goes in production. Yeah, and you're not and a lot of handovers. Yeah, a lot of going in like. I'm doing my stuff. Somebody does the business analysis. They give me the BRD. The BRD goes to the architects and team. They kind of make kind of they build the technical requirements, and then this goes into production. Then the not production, sorry, to being produced to coding. Then it goes to testing. So the testers now are doing that, and there's all that, and then UAT and then production. It's all a very, very long loop. Yeah. But when you look at the architecture side of it, and the biggest problem is the monolith, right? And the biggest problem with monolith is tight coupling. Yeah, it's all around the coupling. Yeah. So I don't know how much we as developers really look at coupling on a daily basis and acknowledge the network and acknowledge failure and all that. But it's really, really a crucial part of how you design stuff. Yeah. And coupling has a lot of aspects. It's not, just you kind of, one component referencing another component. There's like temporal, which is like the time-based coupling, which means that I can't do anything until I get something from you, and vice versa. And if you're down, I can't do anything. Another one would be spatial, like things that are close to each other or need to be close to each other in order to operate well. For example, the web server and the database server probably want to be in the same data center and on the same network and all that kind of thing. Yeah. Another another form that would be platform. Yeah. If you're running on .NET and today, of course, it's all open and it's very easy and all that. But back then, 10, 20 years ago, you couldn't get a Java component to talk to a Microsoft component. Yeah, there's nothing in the middle. Even through web services, they were very kind of they included like very hard tightly coupled kind of platform stuff. Yeah. And there's a lot of ways to solve those problems. Yeah. One relatively new buzzword for that is microservices, right? I don't want to get into a rant about microservices because I come from SOA and I was doing that, I don't know, since 2009, service-oriented architecture, that is. And I've done it in various degrees of success. So yes, some call microservices SOAP 2.0. But in short, microservices are all about breaking down the system into multiple deployable runtimes. Now, breaking down a monolith into multiple bits and having them chat to each other is what I call a distributed monolith, which is even worse than a monolith, because now you have the monolithic problem 10 times or 100 times or 50 times over, and it's super complicated to debug and super complicated to fix and super complicated to find the, if you have this kind of coupling between services and one service goes down and this other service is calling that service, which another service calls it, and so on and so forth, there's a whole kind of chain of failure one after the other, and it's really, it will take you a long time to figure out what's wrong, where does the problem started, and this is roughly what we end up with. Yeah, we end up with like this kind of multiple endpoints talking to each other. In the first days of microservices, and you can argue about that, but let's leave it alone for now. Most of the microservices were talking to each other, communicating with each other using REST APIs, yeah? And I can't think of anything more terrible than that, yeah? Because like once there's a failure, there's a network outage and all that, data gets lost, things get, so imagine again what I described earlier, you're trying to, one service needs some data from another service, it calls the other service, the service doesn't respond, so it goes into a failure mode, it retries a couple of times, then it kind of fails, then the data is lost because there's nothing except in the logs, I don't know what, and so on and so forth, like, it's really an unreliable distributed monolith. I think it's the worst ever. It's the worst combination. So yeah, so how should we solve this? So one of the my guru Udi Dahan, which I've been working with since 2009 or something, puts it like that, and I think it's a very good, excuse me, it's a very good kind of description of the solution. Yeah, address coupling in a software by software design by building loosely coupled and highly encapsulated components. And let me kind of try to describe what that means. So there is this if you don't do a distributed monolith, the next best thing ends up with something like that. Yeah, we put a lot of services that's supposed to be kind of together, but they're not really together. They're not. There's no cohesion there in the code. It's not like a really internal kind of communication. So they end up kind of blurring the lines and needing data from here, data from there, and jumping all over the shop to complete the process. Yeah, where if you could get to cohesion, it would be something like that. Yeah, you have all the things that belong together are talking to each other, are very tightly coupled. They talk to each other, and only from time to time do they communicate with other components. And mostly it would be in a pub/sub kind of pub/sub kind of manner. Yeah, there would be publishing an event that an order has been accepted. So for example, the billing can go ahead and bill the thing, and the shipping can go ahead and prepare the shipping, and when the shipping is done, then it will publish an event, and then the billing would charge the credit card because now we dispatched the thing. Yeah, just an example. But these are kind of that's where you want to be. This is the kind of architecture that you want to get to. And obviously, if we're looking at the deployment model or anything like that, those bounded contexts could be deployed together. Yeah, they could be a single deployment, a unit of deployment. They could be multiple physical services if you want to. Yeah, but as a deployable thing, they would be together because they're tightly coupled, and it's okay for them to be tightly coupled. Yeah. So each bounded context might have a different degree, but they all belong in this bounded context. So I'll explain a little bit about bounded context later, but bounded context, I think, is the key to all this. So let's go back to a little bit to coupling aspects. I just want to kind of, in the context of what I explained earlier, I want to talk about this this aspect of coupling. So runtime coupling is kind of temporal coupling or spatial coupling kind of combined, yeah, and platform. At runtime, components might depend on each other to work. And as I said, RPC or synchronous communication is very prevalent. I've seen this a lot in a lot of places, and I think it's really, really bad. Yeah. And so, for example, as I described earlier, service A calls service B, and service B is not available, then the whole thing falls apart, right? So one of the most obvious kind of fixes to that is using message brokers or queuing systems, yeah, to basically use messaging. What the benefit of messaging is that it is asynchronous, yeah. It's a fire forget operation. You send a message to another endpoint. If that other endpoint is down, it will restart. When it restarts, it pick up the message from the queue and do its stuff, right? Now, obviously, that means that you are looking at asynchronous operations. That means that you need to design your system in an asynchronous fashion. It means that you, again, coming back to bounded contexts, inside the bounded context, you want to have high coupling and low latency, and you want to be able to complete an operation end to end in a good manner, and you expect it to kind of happen quickly. But in between bounded contexts, it's okay if something takes a couple of milliseconds more, a couple of seconds more. So something's down, it will come back up and all that. Now, obviously, for scalability reasons, that definitely is it's beneficial, and I'm not going to get into that right now. But I'm not talking about right now. I'm not talking about scalability. I'm talking about design and loose coupling and easy to maintain kind of system. This kind of approach to help with that. Okay. The other bit that I think is really, really relevant to problems with design is the database. Yeah, most of the design in the old days was based on entities. Yeah, we were kind of saying, oh, there's a user and there's an order and there's a product. Excuse me, and they all are kind of linked to each other. They have some interaction. Because they have some interaction, then we model them as, we put reference integrity between them, and we make it ACID. Yeah, so we enforce reference integrity. And what that means is that if in order to add an order line, yeah, we have to add an order, and in order to add the product to the order line, we have to have the product, and that goes on. I think you know where I'm getting. This means that you need to kind of have a very big operation that has to be ACID in order for this to work. Yeah, where when we're talking about distributed systems, it's not realistic. Yeah, so you can't have everything everywhere ACID and still have loose coupling. Yeah, it's not going to work. It's going to And mostly what I'm talking about here is in the context of writing data. Yeah, I'm not talking about reading data. Reading data is a different problem. I'm mostly talking about writing data, changing state. Yeah. Another thing that's very important here is data ownership. Yeah, I don't know if you've seen this in your code or somebody else's code or code you're maintaining or fixing or something, but I've seen this a lot. Yeah, you have like the one function in the business layer. Yeah, let's say in the monolith space. Yeah, that writes that does some stuff to the user, right? And with time, you know, the code evolved and all that. Somebody in the front end decided, well, why should I go through the objects and this complicated layer? I'm just going to go to the database and write some stuff to the user, yeah. And obviously, there's a violation there because the business logic around how to create a user or what happens when you create a user, or what happens when you update a user, or whatever, all that is gone because now somebody just went to the database and wrote its own thing. Another thing would be like that there are two components that look similar, but because the user table is a user table, then both of them have access to the user table. And they might the boundaries might go with time, they might go kind of blurry, right? So, you know, I might update the phone number, and this other component might also update the phone number, but it's a mistake. Of course, there's a data ownership problem here, yeah? And again, this is all rights, yeah? All when you're writing data or changing the state in the database. I'm not going to talk a lot about bounded context, but bounded contexts is a key concept here for building the correct boundaries and the correct kind of and decomposition or composition to build the correct components and their boundaries and how to make them cohesive. Yeah. Bounded context comes from DDD. I don't know if you know the blue book. I don't know if I have it here. I didn't prepare it, sorry. But the Evans blue book, it's been around for many, many years. I think 15 years now or something, or maybe less. But in his book, he writes about he had put in place the base for DDD, for the domain-driven design. And I'm talking about that concept from the book, but in my interpretation, I guess. So bounded context would be like, if I'm doing something, a full end-to-end operation, that's a bounded context. And the context is the business context, not the technical context. Yeah. So, for example, if I do login, yeah, if I log in or create an account to log in, a login account, create credentials, and log in, this would be one bounded context because it has all the things that we need, yeah, in order to make this login thing available. Yeah. So I need to be able to create an account, to add the user, to add the password, to reset the password, and to log in, yeah, to go in and log out, yeah. And that, in my world, that would be a bounded context, yeah. That would be the thing that's tightly coupled. There's cohesion around what it needs to do, and there's cohesion around what it is, and it can be deployed, you know, it kind of could be its own service. So its own thing with a little UI in the front end, and that would be perfect to serve this one thing, yeah, this one kind of vertical slice of a business function or user function in my system. I hope that makes sense. It's really hard with, you know, being on a virtual stage to gather any kind of feedback from the users, but from the audience, but yeah, I hope you get what I'm talking about. So this concept of bounded context kind of, if you get my drift, it goes into this kind of vertical slicing concept, and to take it even further, this part of the of that bounded context only uses one or two or three, let's say 4 fields of the user logical entity, yeah? The other bits of the user entity might be in the communication or the account component or whatever, yeah, in different bounded context. Each of those are should be, you know, you'll end up, when you take this approach, you will end up with everything, all your entities kind of distributed everywhere, yeah? There'll be, you know, 3 bits, 3 fields over here, 4 fields over there, 5 fields over there, 3 fields over here, but they're not, there is no more this thing of this, you know, user concept, yeah? There is a user ID, and it will be everywhere, in each bounded context, available as an identifier, yeah? But each of those bounded contexts have their own ID, yeah? I don't know, I hope that makes, not own ID, sorry, each of them have their own fields, all sharing the same ID. So I'll leave you with that. I don't want to go too deep into that, yeah? When you're another kind of couple of rules around that, once you get into this kind of area, is that you want to have read and writes. I don't know if you, this is, I'm not talking about CQRS, I'm talking about CQS, command query separation, yeah? So have read APIs and write APIs in totally different verbs or totally different API endpoints or whatever. For reading data, it's a whole different concept, and it's in distributed systems. So it's kind of out of scope from here, but again, treat it as a different kind of concept, yeah, different idea about reading data. In the old world, and I still care and feel strongly about this, we had the OLTP and OLAP. I don't know if you heard about this concept, but it was like the OLTP was transactional data and OLAP was the reporting database, yeah? Business was never able to go into the transactional database and, you know, do a select query that would bring down the database. So always, you know, always think about that when you're designing your read and writes, yeah? Rule of thumb that I could share is that we don't have referential integrity anywhere in the database, and if you can, you know, don't use referential integrity at all, yeah? And again, entities would end up, you know, use your fields, use your bounded context as a guide of what data, of fields of data you're using, and don't think about entities. Entities are not, they're not scalable, yeah? They're not, you can't have one entity that is shared across across different endpoints, yeah? Because of course, then we back to coupling, yeah? Yeah, I think I hope that explains that little bit. Okay. One other thing that I think there's a debate in whether we should, you know, should have a monolithic repository or should have multiple repositories. Yeah. In my experience, it made it every time that we had different repositories, it worked very, very well. Yeah. So each component has had its own repository. It was easier to build pipelines. It was easier to work, you know, to commit code, to do pull requests, to do all of that was really, really easy. So I would go for different repositories. So I have very little time for this session. I'll tell you a quick story about you know, I was an architect in a very successful startup, and we came in, we had all the things and service-oriented architecture and all that, but we had one big monolithic repository. And of course, with time, it all grew, evolved, and a lot of coupling became apparent. And we had terrible time trying to get to move to continuous delivery. At the end of the day, we went on and we split the repositories, and it cost us a lot of time and money. But once we did it, we were on our way with continuous delivery, and everything changed. It was an amazing world to live in, as opposed to where we were before that. So yeah, go for it. I'm hoping that that brought something to the table to think about, and yeah, I'd be happy to answer any questions. This is back to the future, now we're hacking code on introduction, so, but of course in a safe and nice manner. Yeah, so thank you very much.
So
I
thank
think
you.
I'm out of time.
Yeah, thank you, Sean, for your interesting presentation. I can't see, unfortunately, any questions on Q&A chat, so I would like to invite all of you for asking questions to our great presenter. I have one, let's say, question, maybe for the beginning. So if you would recommend something, what we can do today that, hey, we realize that we are in the, let's say, state which you described at the beginning, that, hey, we have one big monolith and so on and so forth. So what would be the first step, the first thought, what we can do in our organization, in our team to start the transformation? So what would you recommend it that way?
So I think the first thing that I would do would be to find somewhere in the outskirts of the system, if you wish, on the outside or a little bit outside the system, something like the email sender or the the PDF converter or the, I don't know what, something like that, yeah. And put together, try and build this one bit of functionality and see if you're getting anywhere, yeah. The next thing, again, it depends if you have APIs, you don't have APIs, but the next thing would be to build some kind of a layer of, you need to basically build a layer of abstraction, like an API or something like that, that enables you to make changes inside and not without affecting the outside, and then slowly carve out, one by one. You need to kind of find the things that belong together based on this kind of assumption, yeah, and model the code first. And if you see the code is working well, then you need to start migrating the data, yeah, to start breaking down the tables, but still all monolith, yeah. This is not, we haven't moved to microservices or anything like that, yeah. And then when you have those vertical slices in your code, then the next thing is to write, build, have a solution, I guess, for each of those components still inside the monolith kind of, space. And once you have one solution for each, then you're in a position to go, okay, now I have I've decoupled as much as I can. Now I can take one piece of functionality out, and then the second and the third, yeah. But don't rewrite, yeah. That, like, forget that bit, yeah. If save yourself a lot of time, money, and don't try and rewrite a big system. Maybe it's a tiny system or it's a POC. Yeah, absolutely, rewrite it all day. And when you get to microservices, you can rewrite all day, right?
Yeah, hey,
Because
exactly.
it costs nothing to create a new thing that does the same functionality, same APIs, but does everything differently. Yeah, so it's not a problem. But does that answer your question?
Yeah, of course, absolutely. And I have another question. Let's say here. So, okay, let's say we saw your presentation. We are getting back to our teams, and we would like to start to implement something. To start to talk with people about, hey, maybe we should change something because we are, let's say, in brownfield, and and any change is really painful for us. So, how to work with people on that culture side, because people are always worried about any changes. So how to work on that culture, on or mindset change within our team.
That is a lot harder.
I think so. So this is
Technical
why I
stuff
asked
is,
this question. Yeah.
yeah, technical stuff is really easy to solve. The culture shift has to come from the top. from the top and from the bottom. You have to find a champion inside like your DevOps guy or somebody who's like operations and your developer that could show everyone how cool it is, yeah, and how good it is. Because at the end of the day, once you move from monolith to continuous delivery, you are going to empower people, and their quality of life is going to become so much better, yeah.
Yeah.
And again, the business is going to be more successful. You're going to be happier. Everybody's going to be happier. The time to market, the time to fix issues is like nothing. Yeah, it's like it becomes a non-issue. Yeah, you just go, oh, there's a production issue. Okay, yeah, I found it because I worked at it yesterday or day before, right? Not 6 months ago, right? So I just make the fix, put it into, go through the pipeline, and it will be in production in a couple of minutes. So it's cool, right? It's a different world to live in.
Yeah, for sure. But always that transition change is really hard for many people. Yeah.
Absolutely. That's one of the biggest. Yeah.
Yeah.
I'm
Even
I'm in the middle of a transformation right now, and I'm telling you, it's like this
it's
is the human factor is the hardest thing, and there's a human thing that they keep on coming back to you and saying, "Oh, it's not working. It's not. Let's just go back to the old way." It was like,
yeah,
no,
exactly.
no, no, you're not doing this. Hold on, like, let's see how this and let's solve this problem, and it's like constant, yeah, because what people want is to go back to the old ways.
Yeah.
Although it was rubbish, they feel comfortable. They
Yeah.
like sitting in their own pile of rubbish. Right? I won't say bad
Yeah,
words.
exactly. It's much harder than that. Let's say technology stuff around this. Yeah, technology is
Absolutely, technology is
all part
very
of
easy.
transformation. Yeah,
Yeah,
it's
yeah,
so much easier. Okay,
yeah.
so very thanks for your answers, for your presentation. It was really interesting, and I hope that people are inspired after your presentation. So thank you.
Thank you very much, Peter. Thank
Yeah.
you.
So now we have 15 minutes break. Now less than 15 minutes break, and we will see on the another presentation. See ya.
See ya.